So here I can say, let us assume that root 5 is rational number. Now, if I say it is rational number, so therefore I can say root 5 will be x upon y, where x comma y are co-prime. That means they don't have any other factor leaving one common between them. Now, if I cross multiply y root 5 equal to x, now squaring both sides, I can say y root 5 whole square equal to x square. So therefore y square into 5 equal to x square. So therefore 5y square equal to x square. So this I am giving as one number. Now this means x square is divisible by 5. So x is also divisible by 5. Now let us say x equal to 5k for some value of k, and substituting the value of x in 1. So therefore I can say 5k whole square will be equal to 5y square. 25k square equal to 5y square. So therefore y square equal to 5k square. I have divided by 5. So therefore it is divisible by 5. Thus it means y is divisible by 5. But x and y are co-primes. So it arises to contradiction. Therefore root 5 is now. Second question says, prove that 3 plus 2 root 5 is irrational, where it is given that root 5 is irrational. So let us assume that 3 plus 2 root 5 is rational number. Therefore 3 plus 2 root 5 should be equal to x upon y, where x comma y are co-prime numbers. So therefore I can say 2 root 5 equal to x upon y minus 3. So therefore root 5 equal to 1 by 2 into x upon y minus 3. Therefore 1 upon 2 into x upon y minus 3 is a rational number, but it is given that root 5 is irrational number. Therefore 3 plus 2 root 5 is irrational. Now, next question says two numbers are in the ratio 2:3 and their LCM is 180. Find the HCF of this number. So, given LCM equal to 180, now let the two numbers be A and B. Therefore, A is to B equal to 2:3. So, therefore, A equal to 2K and B equal to 3K. So, now if I find common factors, so 2K will be 2 into K and 3K will be 3 into K. So, I can say HCF equal to K. Now, it is given that LCM is 180. So, therefore, I can say HCF into LCM equal to 2K into 3K. That is product of two numbers. So, K therefore K into 180 equal to 2K into 3K. So 1K got cancelled. So K equal to 180 upon 6. So therefore K equal to 30. K equal to 30. Therefore numbers are 2 into 30, that is 60, and now next question says find LCM into HCF if numbers are 26 and 95 and verify that HCF into LCM equal to product of two numbers. So here if I find factors of 23 using prime factorization, I will get 2 into 13 and 91, 19 it will be 7 into 13. So I can say 13 is common in both. So therefore HCF equal to 13 and LCM will be equal to 2 into 7 into 13. So that is equal to 182. So therefore HCF of 26 and 91 is 13. LCM of 26 and 91 I got as 182. Now verifying this, I can say HCF into LCM equal to product of two numbers. So let us check that. So LCM into HCF or HCF into LCM, 13 into 182, that should be equal to 26 into 91. So if I multiply 13 into 182, I get 2366, and if I multiply 26 into 91, I am getting 2366. So I can say hence verified. Next question says the degree of the polynomial x plus 1 into x square minus x raised to 4 plus 1. Now we know that degree of the polynomial is the highest power. So here to do that, first I am multiplying both of them. The binomial with polynomial I am multiplying. So x plus 1 into x square minus x raised to 4 plus 1 will be equal to x into x square minus x raised to 4 plus 1 into x square minus x raised to 4 plus 1. So this will be x cube minus x square minus x raised to 5 plus x square minus x raised to 4 plus 1. So minus x plus x got cancelled, minus x square plus x square got cancelled. So now I am left with x cube minus x raised to 5 minus x raised to 4 plus 1. Therefore, degree of polynomial Now, next question says, if alpha and beta are the zeros of the polynomial f of x equal to x square minus p into x plus 1 minus c equal to 0, such alpha plus 1 into beta plus 1 equal to 0, then find the value of c. So here I am given x square minus p into x plus 1 minus c equal to 0. So first, opening the bracket, I will get x square minus px minus p minus c equal to 0. So I can say x square minus px minus common, so p plus c equal to 0. Now, sum of zeros, that is alpha plus beta, will be equal to minus b by a. So that will be minus of minus p upon 1. So that will be p. And product of zeros, alpha beta, will be c by a. So that equal to minus p plus c by 1. So minus in bracket p plus c. So now using this two, let us give this equations 1 and 2. Now using 1 and 2, I have to find alpha plus 1 into beta plus 1. They have given me equal to 0. So here also opening the bracket, I will have alpha beta plus beta plus 1. I have just multiplied the bracket, so equal to 0. Now if you see carefully, alpha plus beta, so I am having in equation 1 and alpha beta I am having in equation 2. So I can put like this, minus p plus c plus p plus 1 equal to 0. So here reason will be using 1 and 2. So using 1 and 2, I proved this thing. I have put the values. Now opening the bracket, minus p minus c plus p plus 1 equal to 0. So now minus p and plus p got cancelled. Now Next question says find the quadratic polynomial the sum of whose 0 is -5 and product is 6. So it is given that sum of zeros equal to -5 and product is 6. So I can say alpha plus beta equal to -5 and alpha beta equal to 6. So we know that equation of quadratic polynomial whose sum and product is given is k into x square minus alpha plus beta x plus alpha beta equal to 0. So putting the values, k into x square minus alpha plus beta is -5 plus alpha beta is 6 equal to 0. So therefore I can say k into x square plus 5x plus. Next question says find the zeros of the polynomial 4x square minus 4x plus 1. So here I can write this as 4s square minus 4s plus 1 as 2s whole square minus 2 into 2s into 1 plus 1 square. So that will be nothing but 2s minus 1 whole square. So that will be 2s minus 1 into 2s minus 1. So therefore the zeros are 2s minus 1 equal to 0 and the other 0 also will be 2s minus 1 equal to 0. So s equal to half are the zeros. Now sum of the zeros will be half plus half, that is 1 minus b by a, and product of zeros will be half. Question says divide the polynomial p of x by the polynomial g of x and find the quotient and remainders. So here if I divide using long division method, x raised to 4 minus so plus 0x cube minus 3x square plus 4x plus 5. X cube term is not there, so I have introduced because I will need, and this will be x square minus x plus 1. So first multiplying by x square I will have x raised to 4 minus x cube plus x square. So changing the signs, now x power 4 term is gone, so x cube minus 4x square plus 4x. Now with x I have to multiply, so x cube minus x square plus x, again changing the signs, x cube term gone, so minus 3x square plus 3x plus 5. So when I multiply it with minus 3, so minus 3x square plus 3x minus 3, again changing the signs, 8. So this is my quotient and quotient equal to q of x, quotient q of x equal to x square plus x minus 3 and remainder Next question says obtain all the zeros of polynomial 3x raised to 4 plus 6x cube minus 2x square minus 10x minus 5 if two of its zeros are square root of 5 by 3 and minus square root of 5 by 3. So here I can say as the polynomial is of degree 3 or 4, thus it will have 4 roots. So root 5 by 3 and minus root 5 by 3 are two roots given, are zeros of polynomial or roots of polynomial, both are same. So if I say x minus root of 5 by 3 into x plus root 5 by 3, so this will be equal to x square minus 5 by 3 equal to 0. So therefore I can say 3x square minus 5 equal to 0 is factor of p of x. Now dividing p of x with that 3x square minus 5. So I am given 3x raised to 4 plus 6x cube minus 2x square minus 10x minus 5 by 3x square minus 5. So with x square I will multiply. So 3x raised to 4 minus 5x square. So minus plus. So 4 power is gone. So 6x cube plus 3x square minus 10x is left. So plus 2x. So I will have 6x cube minus 10x. Again changing the signs. 6x cube is gone, 10x is gone. So I will be left with 3x square minus 5. Now multiplying with 1 I will have 3x square minus 5. Changing the signs I got the remainder 0. Therefore I can say 3x raised to 4 plus 6x cube minus 2x square minus 10x minus 5 equal to 3x square minus 5 into x square plus 2x plus 1. Now 3x square minus 5 factors so already I have. So now factorizing x square plus 2x plus 1 we get x square plus x plus x plus 1. So I will have x common, so x plus 1 and plus 1 common, so x plus 1. So I got two factors x plus 1 and x plus 1. So therefore the 4 zeros are minus 1 minus 1 root. Now next question is if the system of equation 3x plus y equal to 1 and 2k minus 1 into x plus k minus 1 into y equal to 2k plus 1 is inconsistent, then find the value of k. So we know that standard form of two linear equations are a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. Now, comparing both the equations with them, I will have a1 equal to 3, a2 equal to 2k minus 1, b1 I will have as 1, b2 I will have as k minus 1, c1 I will have as minus 1 and c2 as minus 2k plus 1. Now, for inconsistent condition is a1 upon a2 should be equal to b1 upon b2 should not be equal to c1 upon c2. So that means a1 is 3 upon 2k minus 1 equal to b1 is 1 upon k minus 1. So now multiplying should not be equal to minus 1 upon minus 2k plus 1. So minus minus got cancelled. So it should not be equal to this. So I am not considering the third part. I am solving the value of k from the first two because they are equal. Now cross multiplication, I will have 3 into k minus 1 equal to 2k minus 1. So 3k minus 3 equal to 2k minus 1. So 3k minus 2k equal to 3 minus 1. So k. Now, next is an MCQ given. An equation of a pair of dependent linear equation is minus 5x plus 7y equal to 2. Then the second equation will be, okay. So, we know that the first equation is minus 5x plus 7y. Now 2 I am bringing on the LHS side, so it will be minus 2 equal to 0. Now for depending, it should be a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. So if I consider all the four options, I will have only one value where I will have this chance, that is c1. So minus 5 upon 10 should be equal to 7 by minus 14 equal to minus 2 by 4. So see, if I cut 5 ones are 5 twos are 7 ones are 7 twos are 1 2. So I am getting everywhere minus half. So only this option. Now I am given 217x plus 131y equal to 913, and the second equation is 131x plus 217y equal to 827. Then x plus y equal to question mark. So here I can do it like this. See, 217x plus 131y equal to 913, and the second equation is 131x plus 217y equal to 327. If I add both of them, I will have 348x plus 348y equal to 1740. If I dividing both sides by 348, I will have x plus y equal to 5. So therefore Next question says the age of the father is twice the sum of ages of two children. After 20 years, his age will be equal to the sum of the ages of his children. Find the present age of father. So, let age of children be x and y. Therefore, father's age is 2 into x plus y because it is given, it is twice. Now, after 20 years, children's age will be, both will have increased with 20 years, so x plus 20 and y plus 20. So, father's age will be, it was 2 times x plus y, so that, and in that it will increase 20 years. So, therefore, we can say kx plus 20 plus y plus 20 equal to 2x plus 2y plus 20. So, I can say x plus y plus 40 equal to 2x plus 2y plus 20. So, x plus y equal to 20. So, now I got this as first equation. Now, therefore, father's age is 2 into, instead of x plus y, I am putting 20. So, father's age is 2 into x plus y. So, using one equation, I am putting the value x plus y equal to 20. So, 20. So, that is 40. Here I have used